Hello everybody! This year again, BricsCAD is enriched with several new amazing sheet metal improvements. Right now we will show the most relevant of them. Automatic way for transforming solids to sheet metal, rolled edges, jogs flattened curved, flange connected to lofted band, and manipulator for flanges. BricsCAD is known as the most powerful CAD for transforming a solid in unfoldable sheet metal part or assembly. But we are constantly improving. Look at this. We have to design and produce those electrical enclosures. Note that between parts, the flanges angle are different than 90 degrees. On this corner, you can see a classical shape of opening with a small tilted ledge. We start from two solids, representing the first step of design of those two enclosures. We need to transform those two solids in sheet metal and unfold them for fabricating. It seems quite complex, doesn't it? In fact, we click on the two useless faces that must disappear to get two empty solids. Then choose or accept the thickness value, and that's all. Just wait. Look at the result. It's magic. Everything is creating automatically. Everything, reliefs, bends, junction, and cutout. And of course, we can unfold those two parts. This function can be used in many cases. For example, let's have a look to this other example. The door frame of a lift that we have to install in the building. The designer in charge of it, for quickly deliver a project, creates a basic assembly with simple shelled solid. This is classical. As we have to produce it, we must transform the parts in unfoldable sheet metal parts. With any other system, we would have to create the corner reliefs, the bend, the junction, and so on. With BricsCAD, using our automatic function, one click and very hard job, wait. Few seconds. It's done. One more time, everything is created automatically. The project is ready to be manufactured. But the user remained the boss. Look at this particular part. The system logically created a meter, but we can decide differently. Let's see now a nice solution for reworking. Calling the interactive mode, the features are shown with symbols, then you can remove or change. For example, switch bend to junction and remove the diagonal cutout. The unfolding is completely different. Of course, it's always possible to choose a semi-automatic way. Look at this example. Those are two architectural decorative panels. The second one is not rectangular, it means that one side is not orthogonal, and one bend is a conical bend that, in addition, crosses another lofted bend. Consequently, we get a complex edge to manage. We choose to create the bends on the two bottom faces. Then, we select all the side faces and the two remaining curves. And we apply the create junction function. All the junctions are automatically created, including curved junctions, whatever the complexity of the curve, as you can see on this corner. Then, we apply the bend function for the entire model to create bends on the remaining sharp edges. The parts are ready to be unfolded. The complete process takes around 1 minute. For parts with complex junction and lofted bends, it's unique. No one can compete. In the lift assembly, we are facing a problem in the landing door mechanism. We noticed that a part of the gear assembly is too flexible. We have to reinforce it. For that, we can add a flange on the curved edge. We will try two variants. First, with an angle of 90 degrees and a height of 7 mm. Note that we respect by default the original dimension, which is the most probable intent. The result is perfect. As well as the unfolding. Second variant, with the same height, but an angle of 135 degrees. Note that the two unfoldings are of course a little different. Finally, we choose the first proposal. Let's now replace in the assembly. Everything is in working order. Let's go to the cabin roof. We detected another problem. The roof door is a simple sheet metal rectangle and it is sometimes vibrating. We decide to sophisticate a little to make it better holding. First, we remove the original rectangle and replace it by another with almost the size of the hole and it's inside the hole. We hide a part for better visualization. Then we can add a jog on the side. Note that despite the gap is too small, the jog is correctly created. The jog function itself adds an additional gap to avoid collision. We do the same on the other side. Now we will see better in creating a section. Then we see clearly the jog creation. On the other side, we must create a hem to avoid hurting hand in opening the hatch. So we must increase the height of the jog. And the result is perfect. Of course, we can unfold the door. We can now check that all fit in virtually opening the door. And then show the result in the context of the assembly. We must design those two brackets that hold the diode lights in the fountain. We start from a cylinder and we shell it to get a tube. We convert it in sheet metal and create a cutout to make the part unfoldable. Now we can propose several possible options. First, create a jog. You see that the jog is intelligent. It follows the cylinder. Note that despite the gap is not sufficient, there is no collision because the jog creates automatically the necessary space. We can also create a kind of seam in combining two parallel flanges and an open hem. This is perfect. In our case, we decide to create two flanges holded by bolts. First, we give enough space to be able to tighten. Using the parallel option, we create two flanges perfectly parallel and symmetrical. We must add the necessary holes for the bolts. The first one and the second by symmetry. Let's divide the model in two and delete the left side. We will now get the other side by symmetry. You see that we get easily the complete model with few simple manips. We can now easily add the remaining flange as in the final project. Of course, all those parts can be unfolded. You already know the manipulator in BricsCAD that allows linear and angular moving for any selected entities. But we have also a specific manipulator dedicated for sheet metal flanges. Clicking on a face, it automatically snaps to the nearest bend line. We can choose between axis of bend in clicking inside, generally for acute angle, or mold line in clicking outside, generally for obtuse angle. Now look at some possible manipulations. You can see that only the chosen flange is moving. The others don't change position. The manipulator can be used for changing angle, as well as linear position. Let's unfold. we get a first result. Now we can use again our manipulator for one linear moving and one angular moving. All the bends are changed in angle and position, but the model is still unfoldable without problem. This manipulator is also very adapted to be used in the context of assembly. Look at this couple of brackets that hold the diode light in the fountain mechanism near the building. We have to slightly change the light position for more efficiency. For that, we use this manipulator specifically adapted for sheet metal, not that it snaps automatically to the bend line inside or outside, so that the measurable dimensions remains coherent. BricsCAD is clearly ahead in sheet metal CAD. It's not new, but this year again, it increases the gap with the competitors. Thank you for your attention.